So, here's a wild question for you. Can your brainwaves actually diagnose ADHD? Let's get right into it, because what scientists are uncovering is like a detective story, and the crime scene is right inside our own heads. For so many adults, trying to get an ADHD diagnosis is, well, it's a confusing journey, to say the least. Right now, it's mostly about subjective checklists and interviews. And, researchers have found that this process can often lead to misdiagnoses, which is a huge problem. But what if we could go deeper than that? What if the answer wasn't just in what you say, but in something your brain does all on its own? A signal hidden in your brainwaves. And no, this isn't science fiction. Scientists have actually zeroed in on a specific hidden signal that the brain produces automatically, without you even having to think about it. And this tiny signal, well, it might just change everything we thought we knew. Okay, so let's start with the first major clue in our investigation. It's all about uncovering the brain's surprise signal. It's a special kind of brainwave called mismatch negativity, or just MNN for short. So, what in the world is mismatch negativity? Think of it like your brain's own little alarm system. It's an electrical response that fires off automatically whenever your brain detects something that breaks a pattern, specifically with sounds. And here's the really cool part. It's pre-attentive. It happens before you're even consciously aware that something changed. Here's a super simple way to picture it. Imagine you're hearing a steady beep, 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 and then, out of nowhere, boop. That little electrical spike in your brain that basically shouts, hey, hold on, something's different here. That is the MMN signal in action. And look, this isn't just some random idea. Top researchers have actually called MMN a good neuromarker for digging into the brain mechanics of ADHD. So with a clue this promising, the next step was obvious. They had to put it to the test. So let's see how the investigation unfolds. A team of scientists set up this really clever experiment to see if this surprise signal actually looks different in the brains of adults who have ADHD. The big question they were trying to answer was simple, really. Does the MMN brainwave in an adult with ADHD look any different from the MMN brainwave in someone who doesn't? Okay, so here's how they set it up. They got two groups together, one with adults diagnosed with ADHD and a control group without. They had everyone listen to that beep, beep, boop kind of sound pattern. But, and this is the genius part, they gave everyone a Where's Wally book and told them to focus only on finding Wally. The whole point was to distract them, so any response their brain had to the sounds would be completely automatic, all while an EEG was recording their brainwaves. And the results were, well, they were striking. In the control group, every time that oddball sound played, their brains lit up with a strong, clear MMN signal. That surprise response was totally obvious. But in the group with ADHD, that same signal was much, much weaker. It was significantly reduced. This chart just makes it so clear. You can literally see the difference in the strength of that surprise response. For the healthy controls, the bar is high. For the ADHD patients, it's way lower. It's like their brains just weren't flagging that unexpected sound with the same level of alarm. But in good science, you always have to question your results. Which leads us to this really critical question. You always have to try and find the holes in your own theory. Could there be another explanation for what they saw? And here's the doubt that another team of researchers had. Was that Where's Wally book really distracting enough? I mean, what if some people were still kinda paying attention to the sounds? This idea of an attention leak could have thrown off the whole experiment. They had to be absolutely sure that MMN signal was truly automatic. So this second team designed an absolutely brilliant experiment to settle the question once and for all. Their design was so clever. In the first condition, they told people to completely ignore the sounds and just focus on watching something engaging, like a basketball game. But in the second condition, they told them to do the exact opposite, pay attention to the sounds and actually count how many oddball ones they heard. So what happened? Get this. The MMN surprise signal was clearly present in both conditions. It didn't matter if people were actively trying to ignore the sounds or if they were listening closely for them. Their brains automatically detected the mismatch either way. And that was it. That was the confirmation they needed. The verdict was in. MMN is a genuinely automatic pre-attentive brain signal. It doesn't depend on your conscious attention at all. The evidence from that first study was solid. Okay, so the clue is real, the signal is automatic. So what? What's the big breakthrough here? This is where it gets really exciting. Now that they knew the MMN signal was a reliable clue, the original researchers did something incredible. They took all of that brainwave data they had collected and fed it into a machine learning algorithm. The question was simple. Could an AI learn to spot the difference?
The answer? A massive yes. The AI model was able to tell the difference between an adult with ADHD and a healthy control with 81.01% accuracy, just based on their brainwaves alone. Let that sink in for a second. And if we break down the numbers, it looks really strong. That accuracy is over 81%. Its sensitivity, which is the ability to correctly spot someone who does have ADHD, was even higher, over 82%. And its specificity, correctly ruling out ADHD in someone who doesn't have it, was a solid 80%. These are incredibly promising numbers. So let's just step back and ask, why does this matter so much? Because this could be the first potential objective biological marker, a neuromarker, for adult ADHD. We're talking about a move away from those subjective checklists and toward real biological data. This could lead to way more accurate diagnoses, getting people help sooner, and it opens up a whole new window for understanding how the ADHD brain actually works. And all of this just leaves you with one final fascinating thought. If our brains are constantly producing these clear, automatic signals about something like ADHD, what other secrets are they broadcasting about how we think and feel, all without us even having a clue?